Please subscribe my YouTube channel and press the bell icon on the YouTube app and never miss another updates from my YouTube channel. Hey friends, how are you? I hope like everyone is doing great. So after a couple of days, I'm making this first video. So today I'm going to talk about how to integrate Spring Boot with Elasticsearch. So before that, I would like to discuss about what is Elasticsearch, how the internal architecture of this Elasticsearch will look like, and what are the advantages of like Elasticsearch, and what are the key concepts of the Elasticsearch. So those are the things I'm going to discuss first, and after that, I'm going to implement this Spring Boot with Elasticsearch, right? So I already prepared the PPT for this. So let's open this slideshow. So first of all, like what is Elasticsearch? So basically, Elasticsearch is a modern full text search and analytics engine, so which is based on Apache Lucy library. So it is completely open source and built with Java. Elasticsearch is a document oriented database. So it is accessible from RESTful Web Services interface, and uh, it uses like schema-less JSON documents to store the data inside this Elasticsearch cluster. So what is like full text search? The ability to search for the documents based on the content of their text fields. Basically, it will have like searching for a specific terms or phrases within the text of the documents and returning like relevant results. So basically, Elasticsearch will have some key aspects of this full text search, that is like inverted index, tokenization, querying, and analysis. So these are the topics it will internally make use this Elasticsearch, okay, to make the performance better. And so I would like to discuss what is inverted index. Inverted index is nothing but it's a fundamental data structure that is used in information retrieval systems like Elasticsearch. Okay, so it is designed to optimize the speed and efficiency of searching through the large amounts of the text data. Okay, and if you can observe here, we have three documents: document 1, document 2, and document 3. The first one is the cat is black, the dog is brown, and the body is blue. So I just splitted these documents as terms and how it will store inside this Elasticsearch. Okay, so this Elasticsearch uses this inverted index structure to quickly retrieve the documents that match a given query. Okay, so here if you can observe here, these repeating in the three documents. Okay, that's what I have mentioned here. The cat is not repeating, so is repeating in the three documents, right? So when you search for a term, suppose cat, okay, so Elasticsearch look up that term in the inverted index and finds the documents associated with it and returns the relevant documents quickly. So this allows for a efficient full text search capability even in a large data sets. Okay, and so what are the Elasticsearch advantages? Basically, if we're talking about the advantages, so if you're talking about the speed and scalability, Elasticsearch is scalable up to petabytes of data, and distributed architectures, it scale like horizontally by adding like more nodes or like more machines. And full text search, I already discussed about this supports the full text search. And real-time indexing, so basically Elasticsearch uses like indexes that in near real time, so which means that new data can be made available for the search almost immediately. And data aggregations, it allowing the users to analyze the data and visualize it in various ways. So suppose you would like to deal with like min max average kind of data, you can go for like aggregations. And multi-tenancy means like Elasticsearch supports like multiple indexes which can be used to be isolate the data and provide the multi-tenancy. Okay, and document oriented storage, so Elasticsearch store the data as a JSON documents. And schemaless, basically Elasticsearch will store as a schemaless data. So basically it is a schemaless, meaning that you can index and search documents without predefining a rigid schema. And what are the functions? Basically Elasticsearch will support like full text search engine and solve like complex queries and solve like complex calculations, solve other operations that cannot be solved by traditional databases. And it solve like time series data processing such as a log process, infrastructure monitoring. Okay, and So you would like to know, so what are the key concepts of this Elasticsearch before you are going to implement with Spring Boot with Elasticsearch. So first of all, like document, basically documents are nothing but so basic unit information that can be indexed in Elasticsearch, okay, that is expressed in the JSON documents. You can think of document like a row in a relational database. An index means like an index is a logical namespace of collection of documents and their properties. So this is one, the index will save the unstructured data, okay, like we will call as a table in the relational database, right? So like this. And field means like a field is a key value pair that represents a specific attribute or like property of a document, okay. And node, so node is nothing but it's a single server that is a part of the cluster. And shards, basically shards is horizontal partition of an index, it's called shards. And replicas, Elasticsearch will allows the user to make one or more copies of your index shards, okay. And this is how the Elasticsearch cluster will look like. So this is the typical Elasticsearch cluster. So here I have mentioned like node 1, node 2 and node 3, and each node will have an index, okay. Inside the index only we will store the JSON documents, right? So here I mentioned the type, so you can ignore the type for the time being because type will not supported, okay, in the current versions. Okay, I will explain later so why the type is deprecated and which version it is deprecated. So here we have a node, inside the node we have a index, inside the index only we have a JSON documents, right? So each node will have a primary replicas, right? Suppose if one node goes down, suppose if node 1 is a primary node, right? So if the node 1 goes down, so the node 2 will become the primary node. How it will become the primary node? So you can cross verify like this primary will have a replica with this node 2, right? So if the node 2 goes down, the node 3 will become the primary node, so this primary will have a replica of relationship like this, okay. So this is how the typical Elasticsearch cluster will look like. So next, so difference, so if you're comparing like in between relational versus Elasticsearch, okay, if you're talking about the database instance, so you can treat as a node in Elasticsearch, the database as an index, okay. So if you're talking about the table, so in earlier version we used to call table as a type, but type won't be supported in the current version, okay. In Elasticsearch the concept of types was deprecated starting from Elasticsearch version I think 7.0. In earlier versions Elasticsearch you could have like multiple types within the single index, okay. And coming to the row is a document, okay, and column is a fields and schema as a mapping. So these are the terms is very important. You can just make sure that you should have knowledge on this, okay, difference. And so what are the Elasticsearch use cases? So if you go for like any e-commerce websites, on the top we will see the global search, right? So suppose like, so if you want to see like any product related information we will search it, right? So this is e-commerce website. So so facilitated search and personalized recommendations and fast product catalog search. And log analytics, so real-time log processing, search and analysis for like troubleshooting and monitoring. And content management systems also, so efficient content indexing and retrieval including fuzzy matching and relevancy ranking. So fuzzy matching I will explain later. And data explorations, basically if you are talking about data explorations, the powerful search capabilities for exploring the large data sets and deriving the insights. And geospatial search, so Elasticsearch will provide built-in support for geospatial search, making it an ideal solution for use cases and that require searching and analyzing the data based on the geographical location. So I would like to discuss about one dev tool, so that is Kibana. So first of all, like what is Kibana? Kibana is a dev tool, so that allows users to interact with the Elasticsearch cluster via the HTTP requests. So here we have some useful endpoints that can be accessed using Kibana dev tools. So you have Elasticsearch data, you would like to access that data, right? So you can use it this dev tool, okay. So here we have a all the endpoints, okay, get, post, put, delete and get, like HTTP endpoints. To get like a specific document you can mention get and index name and document ID. So posting, so if you would like to like create any document, so you can mention like host, index name and document. Okay, and put to update or creating the document, you can provide index name, document and document id. And the same thing, if you would like to delete any document, you can provide delete index name, your index name and the document id. Okay, and here to get like couple of documents, you can provide get index name and search. Okay, so these are the comments basically, sorry, these are the endpoints you can make use inside this Kibana dev tool. So I already started this Kibana and Elasticsearch in my local machine. Okay, so this is 5601 is a local port for this Kibana. You can just hit this and you can see this dev tools option here, just click on this. Okay, as I mentioned, so here, so get to get the documents product is a my index. Okay, suppose let's search for a couple of documents. So you can see like all the informations. Okay, so stats information and hits and index name. Okay, and inside this we will see this is my document. Okay, id, name, category, price and install. So this is how the couple of documents will look like this. So if you would like to see specifically, you can mention okay document 1. Okay, and same thing, if you would like to delete, you can mention delete. Okay, okay friends, so theoretically we have covered, and now so I'm going to create one Spring Boot application. Okay, so that's why I just opened this Spring initializer. So here I'm going to take in Maven project with Java, and this is my version. And here I just taken like Spring Elastic Java Client as a artifact name, and this is my Java version. And we need like three dependencies. One is like Spring Web dependency and Spring Data Elasticsearch dependency, and Lombok for setters and getters. And let's generate this project and import into your IDE. I already imported to save the time. And apart from these three dependencies, we need one more dependency, that is JSON, Jakarta JSON API dependency to deal with JSON. And so let's open this. So we need like Elasticsearch configuration file. Okay, and this Elasticsearch configuration file have like three beans. Okay, so the first bean is like REST client. So this bean creates and configures an instance of Elasticsearch REST client. So this is a low-level REST client that communicates with Elasticsearch using HTTP request. Okay, so in this case you have defined like uh, whatever that REST client that connects with the Elasticsearch cluster that running on local host at port number 9200. So basically the REST client is used to execute the HTTP request against Elasticsearch, like sending, indexing, searching and other requests. Okay, and the second bean is Elasticsearch transport. So this bean basically defines the transport mechanism for communication with Elasticsearch. Okay, basically it will uses REST client created above as the transport layer here, right? So basically this REST client transport takes care of transporting the request and responses between your Spring Boot application and Elasticsearch cluster using the REST client you have defined here. And the final bean is Elasticsearch Client. Okay, so this bean creates an instance of the Elasticsearch client, which is like essentially high level client that provides more convenient and abstracted API to interact with Elasticsearch. Okay, so it takes an Elasticsearch transport as an argument. Okay, and which you have defined in the above bean, right? So this Elasticsearch client wraps the low level transport details and offers like high level API for performing Elasticsearch operations. So I'm going to make use this Elasticsearch client, okay, in my repository to performing Elasticsearch operations. Okay, let's create domain first. Okay, I already created domain. So this is my product domain class, which will have id, name, category, price, and install. And this will have like data for setters and getters and constructor related annotations. And this is for like ignoring unknown JSON properties. And this is Elasticsearch related document. So my index name is of products here. Okay, and apart from this, this is my id. Okay, and I just defined field types here. You can define the field types if you want. So if you want to define these field types basically based on the Java type, so this Elasticsearch will initiate the types. Okay, and let's create the repository. And let's auto while. So we need Elasticsearch Client. Okay, so let's maximize this. So first of all, I'm going to create or updating the document. So I just use this Elasticsearch Client index method, which will take, okay, index id and document, and it will return the index response, right? So based on that response, so I'm going to construct some content here. So we have a map of methods. So inside that, okay, so what I'm doing is whatever that response I got it right. So based on that response result, I'm just checking the name. So if it is created, I'm just saying the document has been created. If it is updated, the document has been updated. Okay, if both are not, then I'm saying that error has been occurred. Okay, this is for create, and let's create for get document public product. Okay, let's add exception method to signature. So this is basically return. This will return source. Okay, so what I'm doing is this Elasticsearch client will have a get method, so which will accept, okay, one function. So let me show that function. Okay, this function, okay, which will accept some builders here. So I'm just constructing this by using the function, so which will have like index and id and our product type here. So which will return like get response. I'm just constructing from that source. Okay, that is our product. And so let's write for deleting the document here, and Elasticsearch client, okay, delete. Basically this will accept the delete request. So let's construct the delete request here. This will be delete response, right? So now, That's it. So what I'm saying is, if the response result dot name equal ignore quest not found, then I'm saying that document not found with this ID. Okay, if not, I'm saying that document has been deleted. And let's write it for finding all the documents. Anything, so ElasticSearch Client search. So basically this will expect the search request here. So let's construct search request. Okay, so this is my search request, and let's pause. This is search response. So whatever the response we are getting, right, so by using this response I'm just taking the hits and I'm iterating this, and I'm taking as an object here, and I'm just constructed on products list here and just adding this source product source to this list of products. I'm just returning this products here. So now we need to save the bulk API. Okay, so suppose when you have like multiple documents, you want to save it one time. Okay, then you can go for bulk save method. Okay, so this will expect the list of products, right? So let's take Elasticsearch Client bulk API. So basically this will expect the bulk request. Let's construct the bulk request. Okay, so we have a product. So this product I'm going to stream here, and for each, okay, br operations. So I just constructed this bulk request builder here, and I'm just taking this all the products and I'm iterating here. Okay, and let's modify this. So I'm just taking this products and I'm just iterating all the products. Okay, and we have a operations method, so I'm just taking each one operation, and we have an index method. So within that index again I'm taking products index, and I'm just taking ID and document one by one, and I'm just iterating and adding to this bulk request. So I'm just taking this bulk request again and build I'm building this. So this is okay, add exception method to the signature, bulk response. Okay, and if okay, that's it, bulk save also is ready. So now we need a controller, right? Let's construct controller. Inside this controller package I'm going to create product controller. So I already have this controller, so I'm not going to explain much this controller. This is straightforward. So I'm just having this product repository. I'm just auto-add. I'm just making use of all the methods here. Okay, third operations like create or update and bulk and get document by ID. Okay, and this is for like deleting, and this is for find all. So that's it. So let's start this application. Okay, the application has been started successfully on port number 8080. So let's open my Postman. Okay, so let's test one by one method. So let's search all the documents because I already added some data. Okay, I have some data here, some products data. So for okay, so let's get the document. I think sixth document we don't have. Let's check the seventh document. Yeah, we have it. And create the document. So this is ID, name, category, and price and in stack. Okay, let's create this. Document has been created successfully. Let's get it by using our ID. Okay, it's working fine. And let's delete the document. Sixth document gets deleted successfully, and deleted one more. Fifth document as well, right? And let's cross verify here. Fifth and sixth, no data and no data, right? So let's test the final one, bulk save. So here I have two documents, fifth and sixth document, smartphone and laptop, right? So let's hit this endpoint, bulk save success, and search all the documents again, check it out. Sixth and fifth document is created successfully, right? So this is the CRUD operations related to this Elasticsearch client. Okay, okay friends, so previously we have discussed about like how to make use Elasticsearch client for the Spring Boot with Elasticsearch CRUD operations, right? So we have written like all the methods related to that CRUD operations inside that repository, but we have another way. So that way is like I'm going to extend Elasticsearch repository like CRUD repository or like JP repository. So this Elasticsearch repository will provide like all the CRUD operations related methods. So this is another way, right? So this is my controller. Okay, so I'm just using like all the CRUD operations method inside my controller. Save, find by ID, find all, okay, and delete. So this is straightforward. I'm not explaining much more here. And so now I'm going to discuss about the Elasticsearch query DSL. So first of all, like what is query DSL? So it's a powerful query DSL. So that means like domain specific language. So that allows you to construct the complex queries for searching and filtering your data. So we have a couple of queries. One is like term queries, match queries, range queries, multi-match queries, and bool queries, and wildcard queries. Okay, so these are the queries I'm going to explain here. So I already constructed this all the queries to save the time. Let me open this product service. Okay, so first of all, like I would like to discuss what is term queries and what is match queries and what is range queries. So if you're talking about term queries, a term query is used to find exact matches of a term or a phrase in a specific field. Suppose if you are searching for an exact match of a term in a field. So in a field means if you can consider term is a field here. So if you are searching for an exact term inside this category, right? So you can use a term query to find the documents where the category field contains the exact term electronics, right? This will returns that electronics related documents. And if you are dealing with like any numeric field or like boolean fields, then you can go for term queries. Okay, and for talking about match queries, so match queries are like useful for full text search. So what they will do is they analyze the input text and split it into terms and search for the documents that contains any of the terms. Okay, so that's what I mentioned here. So this is match query, and it will perform a full text search on a field with a relevance scoring algorithm. And and it will match the documents where a text field contains any of the specified terms here. So this is one scenario, and another scenario is you can use like minimum should be matched to. So you can specify like how many minimum should be matched, either 2 or 3, right? So match documents where a text field contains any of the specified terms with a minimum should be match requirement. Okay, so and this is about term queries and match queries. Coming to range queries, what is range queries? So here I have written one range query. So let me, yeah. So allow you range queries are allow you to search for a documents where a specified fields falls within the specified range of values. So you can perform either it could be numeric, date, or like string range of searches. So for example, you can use a range query to find a products with price between like 1 to 100 or 50 to 100 rupees, right? So that's what I am constructed here. So we have a range query. I'm just passing the price and greater than and less than. Okay, in between I'm just trying to constructing this query builder. I'm just passing this query builder to native search query. Okay, and this native search query I'm just passing to this search method of Elasticsearch template. Okay, so this is one of the bean I just auto wide here, and I'm making use here, and I'm just getting the content from this search hits. Okay, I'm just collecting it. That's it. The same thing I'm doing for term queries and match queries. I'm just constructing one native search query here and just getting this match query builder. I'm passing to this native search query, and this native search query I'm passing to this Elasticsearch template. Okay, and again I'm passing the search hits to, I'm just getting the content from this search hit and I'm collecting it. That's it, right? So first of all, let's test this all the three queries, and after that we can cover rest of the queries. Okay, so it started. So let's go for, so I'm going to test the term query. So this is find by instance, so whatever that I explained, right? So I'm just passing the boolean variable. Okay, I'm constructing here, and let's check find in stack first. This is a term query, so I'm just checking by passing true or false by checking whether the products are available or not, right? So what are the products are not available? So these are the two products are not available. One is tables, another one is running shoes. And if you would like to see true also, then you can pass it true and you can check it out what are the products are available. So these are the products are available, right? And next one is match query. So match query, so before we are going to check the match query, so let's check it out some of the documents. So I'm going to check the bread document. This is one bread document, another one we have a fresh bread and butter, right? So that's why I'm going to checking. So I'm going to pass bread here, right? So bread is the one of the term here, so it will match all the documents and it will return. So what are the documents contains that bread, because it contains two documents, that's why it's written two documents here, right? So it's working fine, and term and match queries are covered now. So range queries, right? So I think let's check it out. Find by price in between, yeah, this method. Okay, I'm just passing 1 and 100, so in between it has to be written the documents. So let's check it out. 60, 79, 19, 60. Okay, so it's written only within this price range, right? So this is also working fine. So the next one is we need to discuss about multi-match queries and bool queries and wildcard queries. Yeah, multi-match query. So multi-match query means multi-match queries are like extension of match queries. Okay, so they allow you to search for a query string in a multiple fields simultaneously, and they will return the documents that match in any of those, any one of those fields, right? So I'm just searching on two fields. One is like category, another one is name, right? So let me multi-match query. Okay, so here I'm just searching with food here. Okay, so with food actually we have two documents, right? And let's search. Food is category here, right? And I'm searching on name and category. So first of all I'm searching with category, and let's search with name as well, right? It's written two documents. So multi-match queries are also working fine. Yeah, so the next query is bool queries. So what is bool queries? Okay, let me open the code. Yeah, this is my bool query. Okay, so first of all, like what is bool query? Bool queries are combined multiple queries with boolean operator, either it could be and or not, okay, to create complex queries. So they are useful for like constructing advanced search conditions. Okay, so I mean like basically this is like combination of multiple queries, okay, to create the complex queries. So here I'm going to create one example. So that example is sorry, I created one example. So you can use a bool query to find the documents where category is electronics and price is less than some thousand and in stack is true or false, right? So here that's what I mentioned. So category is electronics and price is 1000, less than 1000, and in stack is true, right? So when I hit this I will get, okay, only matching criteria, right? Less than 1000 and electronics and true, right? So it's matching and it's working fine. So the last one is wildcard queries. What is wildcard queries? Let me open my code. So first of all, like what is wildcard queries? Wildcard queries are uh, allow you to search for a document based on patterns and wildcards in the query string. For example, if you have like asterisk, like if you have like asterisk, so that asterisk is uh, used to search for a wildcard queries. Okay, so this asterisk is used as a wildcard to match any character sequence, right? So that's what I'm just mentioned here. So I just have a name keyword and wildcard query builder. Okay, so this will take wildcard query on top of name, and I'm just taking asterisk here, right? This will return the wildcard query builder. I'm just taking and I'm just passing to this native search query builder. Okay, I'm just passing to this again search this Elasticsearch template. uh, I'm passing this Elasticsearch plus template search method, and I'm getting the content, right? So fetch suggestions, let's test it this one as well. So suppose we have a bread, right? So if you search with B, it should be written bread and fresh bread and butter, right? And search the documents, laptop, smartphone. Yeah, suppose if I hit T here, right? Tables and t-shirt. Like this, it will return the suggestions, right? This is wildcard queries. It will make use the hashtag and it will return the documents here, right? I think we have covered like all the queries here, right? So now the next one is I'm going to talk about fuzzy search. So what is the fuzziness basically, right? So let me open this slideshow. So when the user makes a typo in a word, so it is still possible to match it with search by specifying a fuzziness parameter. Okay, so which allows inexact matching, right? uh, so here for string fields, fuzziness means the edit distance, the number of one character changes that needs to be made to one string to make. Okay, leave it this, I will explain. So the fuzzy search will include the terms that have a slight variation from bread based on the similarity threshold. Okay, so let me open my code for fuzziness. Yeah, so here what I'm doing is we have a fuzziness query builder. It will take match query, and on top of name, so you can enable the fuzziness. So we have two types, fuzziness auto and fuzziness one, and you can provide like prefix length as well. Okay, so I will explain this, what is the prefix length and what is fuzziness one. So first of all, like I would like to discuss what is the fuzziness one. Okay, so that's what I'm explaining here. Okay, so the fuzzy search will include the terms that we have a slight variation from bread based on the similarity threshold. Possible inputs are like this one. So if you are searching with like bread, right, so this is exact match. And if you are searching with like breaded here, fuzzy match, so with a slight variation. And we have a bread here, right? So this is also slight variation. We have added S here, and we don't have A here, right? So like fuzzy match, so this is like with slight deletion of characters. Okay, and here we have a addition character, that is yes, we have deleted A here, we have a added S here, right? So let's search, first of all, like let's test this fuzziness auto. Okay, so first I'm going to search with exact match bread, right? So it returned two documents, and the next one is breaded. Okay, breaded, right? It's written two documents, and we have a breads. Okay, it's working fine. Suppose if I delete A here, it is another one. Yeah, yes, delete A, right? And we have breads we already searched. Okay, so like this the fuzziness auto will be work. And the next one is, so this one, this is not required because this one I will directly pass, right? Because native search query already is there. So let's restart this. In the meantime, I will explain so what is this fuzziness one and what is the prefix length here. Let's consider we have an input as a bread, and the fuzziness is set to fuzziness 1 with minimum prefix length of 3. So with this configuration, basically what will happen is the fuzzy search will include the terms that are one character different from bread and have at least the first three characters matching, right? The first three characters we have a bread, BRE, it should be match, right? So what are the possible combinations, is we have a bread, this is exact match here, BREA. Okay, so fuzzy match, so with an edit distance of 1. Okay, here we are replacing D with A here. Okay, and so here we are matching 3. Okay, this is make sure that we should be match exactly 3 characters. So here fuzzy match with edit distance of 1, adding ed at the end. So we are adding the ed at the end here, and breads, so here also edit distance is 1 and replacing D with S here, right? And here this is edit distance again, so replacing R with D here, right? And let's check all the combinations here. Okay, first of all, exact match. Okay, it's working fine. And let's remove D here. That is, okay, it's working fine. And breaded. It's not working. Okay, let's test breads. It is also working fine. Okay, so the last combination, beer, maybe this is wrong, right? So first three characters should be match and last D, right? So this is correct. Yeah, so this is also working fine. So this one is not working, right? So let me test this breaded. So the first three characters are matched. I think one extra, yes, one extra character is added. So this is edit distance of one, adding ed at the end. Okay, so not the ed, so I just added e here. Okay, it's working fine. So like this, we can make use this fuzziness 1. Okay, um, with prefix length of 3, right? And so the final one is aggregations. Yeah, so what are aggregations? Basically, aggregations are allow you to perform calculations and analytics on your data, so such as calculating average, sum, min, max. Okay, so and performing grouping and bucketing operations. We have like couple of aggregations. We have a matrix aggregations, bucket aggregations, pipeline aggregations, and matrix aggregations. Okay, so if you're talking about like matrix aggregations, this matrix aggregation perform the calculations and numeric fields in your documents. So basically common metric aggregations are like sum, average, min, max, count. Okay, so if you want to calculate the sum of a numeric field, or like average value of a numeric field, or like find the minimum value of numeric field, maximum number of numeric field, or like count the number of documents in a set, then you can go for this matrix aggregations. So we have a bucket aggregations. Bucket aggregations is nothing but like it's group of documents into buckets based on the certain criteria. So we have a certain criteria aggregations like terms. Okay, um, so terms means like group of documents by the values of a field. So for example, grouping the products by category, right? And we have a date histogram. So if you want to group the documents into time intervals and range, so create the buckets based on specified numeric ranges. Okay, and geo distance basically groups the documents by geographic distance from a point. Then we can go for bucket aggregations, and we have filters as well. So group the documents based on the predefined filters. And at final we have a pipeline aggregation. So pipeline aggregations like perform the calculations on the results of their aggregations. So they are useful for like creating more complex aggregations by chaining the multiple aggregations together. Okay, um, and we have at last matrix aggregation. So these matrix aggregations perform operations on multiple fields and calculate the metrics across the multiple dimensions. So these are used for like advanced analytics. Okay, so that's it. I'm not going to cover like entire aggregations here. I will show you one example. Okay, for like metric aggregations and bucket aggregations. Okay, so let me open my code. Okay, yeah, so if you can observe here, so what I'm doing is, so I'm just calculating the average price for product in each category. Okay, so we have a native search query, right? So here we have a match all query. So with query we are just passing with match all query, and we have add aggregations. Inside this add aggregation we have a builders. For the builders we need to add by category. So our field is category. I'm saying that by category aggregations. So and sub aggregation is average price. Okay, so this is my field and this is average price sub aggregation, and I'm just building this. Okay, I'm passing the search query to this Elasticsearch REST template search method, and at final we have a aggregations, right? So this search hit will have aggregations, and again I'm doing category. I'm getting the category, and uh, so I'm just checking the buckets here. So this is a bucket category. Okay, so by category aggregation I'm getting the buckets here. So this bucket again will have a aggregations, this average price, and this average price I'm just getting the value and I'm just putting into the map. So I'm just taking here map of string and double, and I'm just returning here. Okay, so this is for like to calculate the average price for each product, sorry, calculating the average price for products in each category. And so if you want to like count the number of products in each category, how you will do it? So the same thing, the different one is we will just pass the category here. Okay, and we will get it this category from this search sheet. That's it, right? Let's test this one as well. Yeah, it's throwing some exception. Reason: disable products. The text fields are not optimized for operations that require per document field data like aggregation sorting. Okay, they are disabled by default. I have field keyword here, right? Yeah, maybe, yeah, let me delete this. Okay, and let's go to this console. So let me delete and reinsert this. Delete products index. Okay, it's deleted, right? So basically we need to use the this keyword on top of this category because we are doing by category, right? So if we are using like aggregations, so you can just make sure that it should be have this field type, right? So let's restart your server. Okay, it's restarted. So we need the documents, right? Okay, search all documents. Okay, I will create some document here. Okay, so let's create another document. Okay, created another document here. Okay, so now let's check the aggregations part. Yeah. Yeah, so now we got count, right? So this is the furniture count and this is the food count, right? So yeah, so you can change this. So where is that? So this is the one, and let's use this one. So to calculate the average price for products in each category, okay, let's go to controller. So this is okay, let's use this. What it's saying? Okay, map of double. Okay, let's restart this. Okay, so started. Let's hit this endpoint again. Okay, so like this you can see. So another aggregation example. So furniture is 700 and food is 60. Okay, So like this you can make use your aggregations so to calculate the average price for the products in each category. Okay, so that's it guys. So if you like this video, so please like and subscribe my YouTube channel. Okay, thanks for watching. Bye, have a good day.